Hi, this is in continuation of my accelerating machine learning model on GPU series, and in the last two videos we spoke about RAPIDS in specific. So in the first video we saw an overview of RAPIDS and how RAPIDS fit into your machine learning pipeline. In the second video we went through an hands-on demo of developing your first machine learning model using RAPIDS. Basically, we used cuDA dataframe and cuDA machine learning libraries and developed our first random forest model. In this video, we are going to more specifically go into detail on cuDF, which is the cuDA dataframe API, which is a drop-in replacement of pandas, Python pandas. So before getting there, if you see, basically this is the functionality of RAPIDS. If you see on the top, basically RAPIDS allows you to manage the data via cuDA dataframe. Basically you can build your future engineering pipeline, you can do kind of slight data wrangling, and then basically on the training side of it, it uses QML, which is the machine learning library, which is again a drop-in replacement of scikit-learn. And finally it allows you to even visualize the model and deploy. You can deploy on NVIDIA, RTX and everything. So it allows you to inference the model as well on GPU. Now the advantage of the cuDF over here is basically you can have everything GPU driven end-to-end in machine learning, rather than creating in a pandas pipeline and then moving the pandas pipeline into an GPU memory and then processing it. Basically using cuDF you can develop an end-to-end machine learning pipeline using RAPIDS itself. But one point over here is cuDF as such will not give you pretty huge benefit if your data size is not very huge. Because pandas itself is an in-memory computation, it loads it in memory and it processes the data. And a lot of the future engineering work we do, it is not really GPU driven. That is not huge matrix multiplication or something like that. It's just simple massaging and processing of data, which is more CPU intensive task rather GPU intensive task. The only advantage it can come in when your data set is pretty huge that cannot fit into your single node memory. Basically RAPIDS uses DAS to distribute on multiple GPUs. That is one benefit of it. The second benefit, as I stated, you can build your entire pipeline and finally take the pipeline and deploy completely on GPU. So this is the functionality of RAPIDS, and today we are going to talk about cuDF. As I said, it's a data frame API. If you have seen my previous video, I have already showed the installation steps. In case if you have not seen the previous video, you can click the link on the top where you can go to my previous video and watch the installation step. I have already installed the RAPIDS package here. It's a collab notebook. The notebook is available in the video description. You can click on it and play around with it. It takes some time, so I have pre-installed it. Basically you need to execute these two steps. Now once we are done with the installation, what I am doing is I am importing two packages, namely the cuDF, which is the RAPIDS data frame package, and as I said, it's a pandas drop-in replacement. So most of the functionality of pandas is built into cuDF. The cuDF is still evolving, so not all the functionality of pandas is available, but over the time you can see like lot of functionality coming in. DAS cuDF provides parallelization to cuDF. So basically if cuDF can run on a single GPU, you can use DAS cuDF to run on multi-nodes and multi-node and multi-GPU. And NumPy is your regular library, regular Python library. So now if you see over here, rather than using the pandas over here, I'm using cuDF to read CSV. It is very similar to pandas read CSV method. So I'm kind of pulling up an data set. This is the Portuguese bank marketing data set, where basically we are predicting whether a customer will buy a term deposit or not. This is available in the UCI machine learning library, but because it's a zip file and to make it simple, I just pulled it into my GitHub repo, and you can download the file from there as well. So I'm reading the file, read CSV, and assigning it to an data frame. Yeah, again, this is a GPU data frame. This is not a CPU data frame. I will show you the output in some time. Now quickly, like you can to see what are all the methods available in cuDF. you have read CSV, which is the which is one of the method, and then you can read multiple format. You can read an Avro file, you can read an HDF file, you can read a JSON file, you can read a ORC file and Parquet file. So if you already have a big data ecosystem, and if your data is in ORC or Parquet format or even Avro format, you can load that and also you can process it. So basically it supports multiple format over here. But I have a CSV file now, so I'm going to more demo CSV file. So let's quickly verify the shape. It's if you are really seeing it, it's more like pandas function only, and I am visualizing the first few rows. So the first few rows, if you see, it's a combination of numerical and categorical value. You have age, job, marital status, whether the customer has a default in loan, existing loan or not. What is the balance he has, and these are all like the basically input feature set. And finally the output is the Y variable, where we are predicting no or yes. No means the customer has taken a term deposit. Sorry, customer has not taken a term deposit in the marketing campaign process. Yes means the customer has taken basically a term deposit. And the idea is to predict whether based on this data set in future, whether this customer will be taking one of the term deposit product. Now you can interchangeably use pandas and numpy as well. I'm just showing this in an example. I'm just taking the Y data frame and converting into numpy and seeing like what are the different values available. There is yes and no. You can also use internal cuDF values, but just to show, like you can move the data to pandas using two pandas, and then you can process, you can run your typical pandas, matplotlib and other visualization library. I have in a detailed walkthrough I have done in my previous video where I have taken a pandas data frame and converted it to cuDF and then using it. But in the further on, it will be purely on GPU data frame. So let me run the NVIDIA SMI again. Now if you go on the top, the NVIDIA SMI, so basically you can see only 0 MB is occupied. Basically I have not loaded anything, but after that I loaded the data frame, and now if you see, actually like there's around 385 MB of data loaded, MIB of data loaded into the GPU memory. So now the data is there in the GPU memory. Any functionality, any data analysis or data processing functionality I do now here on will be happening on the GPU. Now I've just given this is available again, the UCL library. I've just copy pasted what the different value, what the different futures mean and everything. But in this video we are not going to go into the details of explaining the data set. This is more like providing you with what the data frame API is about and what are the functionality available. But in case if you are interested, want to play around, you can just look at the data and play around. So now coming back, I'm just printing the number of rows and columns. There are around 45k rows and there are 17 columns, and the data type is basically mostly object and in64 over here. I'm quickly checking if the data set has null. Similar to pandas, how we do, the data set does not have any null columns over here. Then I'm doing a basically value count. I am seeing the distribution of the target Y variable. So if you really see here, most of the data pertains to no. There is few data which is pertain to yes. So it's a pretty highly imbalanced data set. Now when you're developing a model, you need to see whether you want to do upsampling or downsampling and everything. But here only it's analysis that we'll be doing. I will go into the detail of the analysis and different function, but quickly, like what I'm doing is I'm trying to also quickly show the functionality of DAS cuDF, which is an which partitions your cuDF. So basically in the first one, what I am doing is I am just doing a describe of the data set. So I'm just benchmarking its start time and end time, and if you see, it took around 0.05 seconds on GPU, and then I'm distributing it using Dask in partition 2 and I'm running it. You will not see much benefit. In fact, it will be sometimes worse as well. As you see it taking 1.5, and when I run it again, maybe it's a little faster. If you see over here 0.3 still, it's still higher. As I said, not all problem is an GPU problem. A lot of the describe or engineering work we do, maybe it's just a CPU problem that we have, so you may not see benefit. But if you have multiple nodes, if you have a pretty huge data set and it's residing on multiple nodes, then basically you can use DAS cuDF to split the data set. So say I have like 10 files and I want to load the 10 files and then do an analysis, then I can set the n partition 10 and I can distribute across multi GPU or multi node and then fasten the process. But since I don't have multiple GPUs here, I just want to demo the functionality. In this, what I'm doing is I'm converting the CUDA data frame to task cuDF, and then I'm partitioning into 2. So basically I'm telling the parallelism as 2, and then I'm benchmarking it. Now, typically, if you want to visualize the distribution of data set, all the numerical data set, you can see basically how the data set looks like and everything. Now, what I'm going to do is I am going to basically do an analysis of the target variable with individual features. So more kind of an univariate bivariate analysis is what I'm going to do with the data set. The first one I'm going to do, what I'm doing is I'm checking whether the marital status has any relevance to a customer taking a term deposit or not. So if you run here, so what I'm doing is it is grouping the marital status, whether the person is divorced, married or single, and then I'm doing an mean of the balance and checking whether what is the balance in each of the output y variable bucket. So basically in this case, if for the customer who are taking, yes, you can see here, the customer who are taking a term deposit, typically the average balance is pretty higher than the person who are not taking it in all the categories. So you can see basically here it's 1707, it's 1107, 1915, 1370. So the thing is, like, if the balance in the account is more, there's high probability the person might take a term deposit. That is one of the things. Now I'm going back and creating a separate column for Y and seeing like how many people took loan and how many people did not take the loan. So in this case, if you really see basically if you just do a rough calculation, 4585 people did not take the loan in the diverse category, and when it says yes, it's 622, and similarly married. So if you quickly see, like, basically around 12% of the people are taking, but when they are single, you can actually see the term deposit is higher than the norm. It's around like 19%. So it says like if single means they are more probable to take and term deposit. Again, this is just a correlation based on data, not a causation. So I'm just doing some analysis to quickly show how the data frame API will work. I'll go into some complex analysis, but just to quickly show. Next, I'm trying to visualize based on the loan data. So what it says, whether that particular customer has a previous loan. So if they have a loan, what is the probability of they taking the term deposit? If they do not have a loan, what is the probability of they taking the term deposit? So here, if you really see, you can quickly see, right? Like when they have a loan, they are around 8% or 7% probability to take a loan. But when they do not have a loan, they are around like 11 or 12% probability to take a loan. So basically, when they do not have a loan, they might have they don't have any commitment to pay off that debt. So they might, you'll as well look at saving money by term deposit. So this is one thing. I am similarly doing this for basically multiple. Wait just a minute. Yeah. What happened? Okay. Sorry. I'm just similarly what I'm now doing is I'm assigning this value, whatever we did on the top, to an output variable loan outcome, right? And then I am calculating the percentage in the total category. So what I'm doing is I'm taking the Y value of the loan outcome and then dividing it by loan outcome dot sum to just quickly see an percentage. So if you see the output now, basically the Y percentage, you can see just a quick distribution of data. And one more function that I can do is I can do an apply map function. So in this case, I'm taking the duration column. The duration is the amount of time basically the call center agent spoke to the customer in the previous contact in seconds. So what I am doing is here I'm defining a function over here that will basically take the duration and convert into hours. So that is the function over here, and then I'm taking the duration column and applying the map function to convert hour. So it will take the seconds and basically convert it into an hour, and I am assigning it to a duration hour column. So now if I visualize the banking data frame, basically you can see here, if I go to the end, So basically you can see that is a duration column which is 261, and there's a duration hour column which is like converted into hour. So this is the other way. Similarly, I can quickly see the kind of based on balance, what is the basically how the y variable, output variable is, and for based on the campaign. Now campaign is basically how many times the customer was contacted to take a loan. To take a loan. So what we are trying to see, whether the more time the customer is contacted, maybe the customer takes a loan, or maybe sometimes the more time you contact, the customer may not be interested because he has already made mind he's not going to take the loan. There's no point in calling him again. Right, so basically I'm just grouping it. I don't see much difference over here. So basically if you see basically like 2.14 and 2.84, it shows that the lesser contact, the more probability they may take the term deposit. But let's go into the detail and quickly do a quantile and check. So what I'm doing is I'm doing multiple quantiles of the campaign column. The reason is I want to check whether there's outlier. If you really see, there is a 63, most of the 95 percentile of the value lies in 8, but there is one column that is completely outside of the quantile. So basically it is an outlier, and that's why if you see, maybe it's showing a balance. So what I'm going to do is I'm going to kind of do an analysis without the last column. So what I'm doing is I am creating the bank data frame, and I'm using the query function. In query function you can give like kind of a more English like value, like campaign less than or equal to 8. You can give hand function, or function. You can give little complex functions as well to filter out the data. So what I'm doing is I'm querying the data, filtering out the data, only taking the value where campaign is less than 8 based on the 95 percentile value here on top. So once I run this, I have this bank campaign data frame with less than 9. Then I am kind of doing the campaign analysis of the y variable. So if you see over here, basically up to 1 to 8 it's telling yes or no. So you can basically quickly visualize and see, okay, on the top the conversion is around 15%, and as it goes down, if you come to the bottom, basically when it's 8 and basically 7, it's only like less than 6% or 5% conversion that we are seeing. So it kind of gives an intuition that if a customer really want to take a term deposit, maybe in the first campaign or second campaign, you really contact them, they may already have taken it. So that is, after one stage, you don't have to really spend money, your marketing money on that campaign, right? So that's what it's about. Similarly, I can do based on education, what are the different, how is the data distribution based on education. So this is how, and then I'm grouping by education and seeing how the target variable responds. So the point I'm trying to make over here is it is pretty similar to your Pandas data frame API. You can take the data, you can load it into GPU memory, and then you can kind of do a quick processing. Now in this case, if I had run in Pandas, it would be faster. The only thing is when your data set is very huge, where Pandas cannot operate on, and you have a pretty good GPU with a good GPU memory like 64 GB, which you can completely move or something like that, and you also have multi-node, multi-GPU system, you can distribute your processing and then get a faster result. Now coming back to the QML, right? If you've seen in my last video, basically it was able to run a random forest model pretty fast. Within like 5 seconds, it was able to run a random forest model with some 250 trees, 250 models, 250 trees and 8 node depth, which was very fast compared to if you were running a scikit-learn, the model would have taken like at least some 2 minutes or 3 minutes. We are going to do a benchmarking in the next video, but just want to show the data frame API. You have seen the machine learning API in the previous video, and then let's go to benchmarking now that you have an understanding of how these different components work together. Thank you.